All right, guys, this is the last lesson in this first unit on linear functions. I am sorry that I'm not here today. I am at a training for something that I do within the district. So this lesson is not super difficult, and honestly, the hardest part about it is understanding and learning how to use our calculators for what we need it to do. So your sub should have given you a list of calculator directions. They go literally button by button. So make sure that you are practicing that, making sure that you know how to work your calculator. If you are having issues, see me tomorrow in academic lab and we can figure it out. Okay? So what we are talking about today is fitting a linear function to a set of data. Okay? So here's why. Why do we do this? In general, data obtained from real life events don't fit perfectly. Okay? It's very hard to find a situation in the world that's a perfect linear relationship. Okay? But a lot of times we'll still use a linear function to help us analyze the data or model the data. We talked day one about a math model. This would be considered a math model. So talking about what we call linear regression. So let's look at an example first. It says the data points from a crankcase motor oil producing company is listed in the table below. They want to study the correlation between the number of minutes of TV ads per day for their product and then how that correlates to the number of oil cases sold per month. So what you see in the table, your input is the minutes per day for the TV ads, and then the corresponding units sold in millions for that number of TV minutes. So you can see the data points there. Below, you can see a scatter plot of that data. So the question is that you can see, what does this data look like? Well, it looks pretty close to a straight line. Resembles a straight line pretty much, okay? What we can do is we can draw what we call the regression line. And what the regression line is the optimum, meaning best, the best linear function that describes the data. The method that we use to find that line, which is what our calculator does for us, is called the least squares method. I had a math class in college where we had to do that least squares method by hand. Let me tell you, it's tedious and not very fun. Luckily, we have these. All right. If you want to know more about that least squares method, I think your book talks about it a little bit more in depth about how it works, so you can go there if you want. So what you can see then finally is that regression line. I want you to notice that many of the points are not exactly on that line, okay? And there's about the same amount above the line as there is below the line, okay? That's the best line to fit that data. Alrighty. So I used the word correlation in that opening example. So let's talk about what correlation is. Correlation is how something relates to something else. What we call the correlation coefficient is it describes how well a regression line fits the data, okay? The variable that we use for the correlation coefficient is r, lowercase r. This value will be between -1 and +1. If r is equal to 1, the data fits a line with a positive slope exactly. Okay. If the correlation coefficient is 1, that means the line perfectly fits all of the data, and the data would be actually linear. If your value of r is negative, this is fitting a line with a negative slope. If r is positive, that means it's fitting a line with a positive slope. If r is equal to 0, that means the data is completely scattered. There's no relationship there. Okay. All right. So I have some examples of data sets and then corresponding correlation coefficients. So you can see how the correlation coefficient looks in terms of some different data sets. So if your correlation coefficient is 1, that means, again, that your line fits exactly all of the points. If your value of r is 0.8, that means it fits it pretty well. It has a high positive correlation. 0.3, we're getting closer to 0. It's going to have, that says a low positive correlation. Here in the middle, again, if it's 0, that means there is absolutely no correlation at all. All those points are completely scattered. Then going negative. So understand that a negative number doesn't mean that there's no correlation. That means there's a low negative correlation, meaning there's a low correlation for a line with a negative slope. Negative 0.8, there's a high negative correlation. So that means the 0.8, that's getting closer to -1. There's a high correlation, but for a line with a negative slope. -1, perfect correlation, negative slope. Okay? All right, so the very last thing is actually finding the line. So here's where you really need to make sure you have those calculator directions and try to follow along with the video to do this, okay? The very first thing that you need to do every time is to clear out your lists. These are things that you probably haven't ever used before unless you took AP Stats, which I know some of you did. So what you need to do is go second plus sign to your memory. Go down to number 4, which is clear all lists, hit enter twice, and then it will tell you done. Okay, that just ensures that you don't have any random numbers in your list. That would affect your line. All right, then the next thing that you are going to do is you are going to put these data points in your list. So you're going to go stat, number 1 is edit, hit enter, and then you'll have your lists. They should be empty. For L1, you're going to put in all of your input values. Okay, so just type 110, hit enter in between, 105, when you're done with that, just scroll over to list 2 and enter all of the corresponding output values. And just double check. You should have the same number of input as output. Just double check that you entered those numbers correctly, okay? Once you're done with that, then you can hit second quit, okay? And what we are going to do is we are going to get basically the slope and the y-intercept of our regression line, okay? So we need to go back to stat, but this time we're going to go over to calc. Under calc, we want the linear regression line. So I scroll down to number 4, hit enter again. Some of the newer calculators, you have to scroll down to where it says calculate and then hit enter. So you should be getting these same values. If you're not, try it again, try to fix your issue. What you are given is kind of the general form. So they're telling you y equals ax plus b, and then the values of a and b, basically the values of your slope and y-intercept. So what you're going to do is take those two values and you're going to write your equation, okay? So that's to get your equation. Now to get your correlation coefficient, this is in a different place. For this, go to VARS, V-A-R-S, go down to number 5, statistics, and then you need to scroll over 2 menus to EQ, and then your coefficient is number 7. Hit enter, enter again. So our correlation coefficient, our value of R is negative 0.539. Okay? Now, to graph this, okay? And again, all of these instructions are on that sheet that you should have received. Now to graph this, you need to go to second y equals, where it says stat plot, second y equals, and you need to turn your plot on. So just click number 1, click on, and then you can quit it, okay? Then go to zoom. Number 9 is zoom stat, okay? Number 9 is zoom stat. That automatically adjusts your window to fit those points. So you have your data points. Now what we're going to do is go back to our y equals, and I'm going to clear out what I have in there. And I'm going to type in our equation. And then I'm going to hit graph again, and you'll see that not only now do you have the points, that you also have the line too, so you can kind of see how that fits, okay? All right, so last couple questions. Graph the least squares regression line, we did that. What does the correlation coefficient tell us about the data? This tells us negative 0.539, that there is a relatively good fit to the negative sloped line, okay? So please, please, please make sure that you can go through those steps on your calculator. Make sure you are getting the right thing. If not, see me tomorrow.